All right, the purpose of this video is ultimately to provide another tool to solve proportions and hopefully make them a bit easier. This is a challenging topic, so um, hope this helps. So we begin with a theorem here. Two fractions are equivalent if and only if the cross products are equal. Okay, what is that saying? First thing I want to point out, remember a fraction, we've worked a lot with ratios, right? A ratio can be written as a fraction like a over b or a to b, um, and of course b over a or b to a. Now, this cross product you might not have heard yet. So I'm going to write this mathematically. Ultimately, in math, we want to be concise and we don't want to write a paragraph for every problem. So what this theorem is saying is this. We have two fractions. They're equivalent. Remember, equivalent is a form of equality, means they're equal. So those are equal if and only if their cross products are equal. The cross product, let me grab a different color. Okay, we look across and remember product means to multiply, right? So if I take this numerator a multiplied by this denominator d, whatever that numbers they are, and if that equals the product of the other two multiplied, right, the other two across from each other, then I know those fractions are equivalent. Even better, that also means we have a proportion, right? A proportion is exactly this here. If you have two ratios that are equivalent, then we know it's a proportion. Likewise, in math, you'll begin to encounter this if and only if. That also means if you had started over here, if you had two products, you could actually decompose and write a proportion as well. But usually, we want to check for proportions. All right, that's the theorem. That's the generic side. What the heck are you saying? What does this look like with real numbers, right? Now, hopefully you have the tools to do this example problem without this trick. We either try to simplify the larger numbers, right, with the 8 over 12, try to find a common factor we can divide. That we need that. I mean, there's no doubt about it. Or we try to see what we can multiply the numerator and the denominator by. Is there the same number we can multiply for both of these? And if so, then they are equivalent. But I'm going to use a theorem. Right? The theorem says if we took this 2 multiplied by the 12, and it in fact is equal to 3 times 8, then we know those fractions are equivalent. And both sides do in fact yield 24, so yes, they are equivalent. All right, there's a bigger purpose here, right? The end goal was proportions. So I changed this just slightly to say, well, what if I don't know one of these, right? What if we're solving this proportion? You may have used X, you may have put a question mark, you may have a box. Ultimately, it doesn't matter. This is our unknown. Now, I know it because I chose the same numbers as above, but I wanted to do that for this demonstration. So using this theorem, we have a proportion if and only if their cross products are equal. Okay, that can be proven. It doesn't matter that we're just going to use the theorem. So I know that if I took some number multiplied by 12, right, it doesn't matter again if you put X or box or whatever. That should in fact equal 3 times 8. So some number times 12 I know should equal 24. It takes a little bit of thought process. I mean, maybe you need to write your multiples. Um, maybe you know 12 to a certain extent. But again, I'm slightly cheating because I use the same example. I do know, in fact, 2 times 12 is 24. So therefore, I know to complete this proportion, that would be a 2. All right. Now, this works for all numbers, right? I mean, you could have a crazy fraction and maybe you don't want to go through the work like we did up here. Or maybe you have a proportion and it's becoming tedious. You could do this cross product. Word problems, right? Proportions and ratios, you've seen plenty of word problems. This one is going to yield the same result, but I did want to just throw it out there to make that connection and close out this video. During our fundraiser, Landon sells 12 chocolate bars in the same amount of time that Emerson sells 8. If Landon sold 3 bars before school started, how many bars is Emerson projected to sell during that same time? There are many ways to set this proportion up, and in fact, we could read through it and make this connection and get the same proportion as we had above. Okay, how? Well, we could look at it like I am going to write Emerson's, all of his cells is going to go in the numerator. Okay, I'm looking at the ratio, right, compared to Landon. So I do know that Emerson sold 8 in the amount of time that Landon sold 12. I'm sure you have learned some tricks about, underline or box in data. Keep using those tricks. This video is not about that right now. So the proportion, now I'm looking at the before school, right, is the next important piece. I don't know how many Emerson sold. Okay, that's the unknown. That's my X or box or question mark. It's a variable. But I do know Landon sold 3. Question is this the same problem as this? And yes, right? No matter how you write an equal, I could change this. It's still the same problem. It's an equal sign. When two things are equal, it doesn't matter which one comes first. Now, what if someone else set up their proportion, though? Well, I use Landon, right? The ratio Landon, and I'm going to even write it this way, to Emerson. That's okay. As long as you're consistent, proportions will work. So what would that look like? Well, Landon sold 12 in the amount of time that Emerson sold 8. Before school, Landon sold 3. I don't know how many Emerson sold. Remember cross products. It boils down to the cross products based on that theorem. These are equivalent if we multiply the diagonals, the cross products, and we get the same result. So 12 times some unknown is equal to 8 times 3. Now I know we did this problem above, right? So we already know the result. It's 12 times 2. So we know that the unknown is 2. Again, there are many ways to set this up. You could have also, one last way, let's stick with Landon. Like we could do the total compared to the morning. That's one more ratio. So if I stuck with Landon on this side and Emerson on this side, Landon sold 12 total. Emerson sold 8. In the morning, Landon sold 3. Emerson, we don't know, right? We're trying to find that out. Check out the cross products. It boils down to the same thing over here. All right, hope that helps with some proportions.